Today we're going to take the red pill and we're going to discover how the matrix can help us solve vector equations. Well, there's two ways that we can multiply vectors together. One is called the dot product, and obviously we can represent this with a dot. And then the other way is to use the cross product. This is the cross product, and we can represent this with a cross. That's the X symbol right there. And let's use two classic examples. We're going to use work, and that's going to be equal to force times distance, and that's going to, we can represent that with an F dot D. On this side, we'll use torque. Another classic example, torque equals R cross F. All these things should be vectors. And it turns out that here on this side, the order doesn't matter. So if we want to really make this stuff look very, very similar to itself, we can even swap these. Let's swap these two real quick just to make it D dot F. Now we can see that it's going to be D dot F and R cross F. On that side, the order does not matter. On this side, the order matters. The way that we order these will matter because we're going to build a matrix on this side, and on this side it's very simple. Let's translate these equations from these dots and these x's into actual algebra. So let's go like this. We can say that df cosine theta. That's what the dot product really means. And on this side we have the cross product, which says rf sine theta. That's really what the cross product means. If we kind of imagine this on our in directions, let's say this, notice these are directions. So if these two vectors were in perpendicular directions, if this was the distance and this was the force, then these two would dot together, would multiply together to get 0, because the cosine of 90 degrees is 0. So that would just go away. But if these two forces are either perpendicular to each other, and it could be in this way or that direction, either positive or negative, this would give you a 1 or a negative 1, of course, right, if they were opposite, let's say. So this direction and that direction, right? So here's your D and here's your F. This would be either 1 or negative 1. And so that would give you an answer. So work is equal to, basically just df at this point. Very simple. It's very simple here. The dot product is just multiplying them together. Now this would be easy if it were just magnitudes, but if it were components, at that point you would have this I plus j situation, maybe even a plus k if you're looking in 3 dimensions. And so how can you multiply this stuff together? Well, it's not that difficult. I like to think of it as II plus JJ plus KK. This is kind of how I like to see the dot product. Double I, double J, and double K. That's because when you are multiplying these things together, let's give yourself, I don't know, 2I plus 3J plus K. And then we're going to multiply that, or rather dot that, with another vector. I don't know, negative I plus 2J minus 3K. Keeping things pretty easy. If you just want to multiply this stuff together, it's pretty simple. You're just going to go 2 times negative here. The two i's will fit together, so it's 2 times negative 1. I'll put that negative 1 like that. And this is the I. But it's double I, really. These two i's are going to multiply together. Forget all the rest of this stuff. You don't have to worry about foiling. Usually you would want to foil all this stuff out, right? But you don't have to. You don't have to do all that stuff. Everything's going to cancel out because if you were to multiply I and J together, Imagine this as, let's just go ahead and erase all this other stuff. It's a little unfortunate. But let's say if you were looking at a coordinate system over here, here's your j and here's your I. You multiply these two things together, remember, this is 90 degrees, so this becomes 0. So ij makes no sense, this is just 0. And so the only thing that's left, if you try to FOIL this out, is just going to be ii, that's going to equal 1. ii equals 1. That gives you an answer. Continuing this out, we're going to do ii, and then we're just going to add the next one, which is going to be 3 times 2. Okay? And that's jj. And then we're going to add the next one, which is just going to be 1 times negative 3. And that's going to be over here, kk. Alright. So these things will all cancel out. Okay, this becomes 1. This becomes 1. And this becomes 1. So that's why this stuff just becomes a scalar. I may have mentioned that or may have not mentioned that. But on this side, all we get is a scalar. That just means we get a number. We're going to get a number here. Work is just equal to some sort of amount of joules. So we're just going to get, if we added this all up, negative 2 plus 6 plus, and then here's a minus 3, minus 3. That's going to be negative 5 plus 6 is negative 1. Bam. Negative 1. That's negative 1 joules. When we dot these two vectors together, this whole 2, 3, and then 1, and then negative 1, 2, and then negative 3, if we dot these two together, multiply them out, we're going to get negative 1 joules is equal to the work. So the dot product's relatively easy. You just get a scalar, and that's what the scalar is. The scalar is just a number. But let's look again at the cross product. If I delete all this side, and remember that we had torque on this side was equal to R cross F. This is the cross product. Well, the cross product is a little bit more interesting. The cross product will have to deal with matrices. We're going to get a vector at the end of all this. Well, that just means that you're going to get this whole I plus J or plus K component out of all that in the end. Well, let's just try to set this up. So when you have to do cross products, the first thing I like to do is, well, first we need our vectors. So let's just get rid of this and let's put some vectors over on this side. We'll just say we've got, what did we have before? Didn't we have like 2i plus 3j minus k? And then we also had like a negative I plus 2j minus 3k or something like that. Don't remember exactly. Let's try to cross these two now instead of dot them. Well, okay, let's set this up like this. First, we're going to want to set up like this crazy matrix thing. We're going to go I, J, K on top, one line right here, and then we can go. This is why the order is really important on this particular on the cross product. The order matters. I'm going to rewrite that. On this stuff, the order matters. Order matters. Alright? Because remember what the order was over here. It says R, F. That means that R goes on top and F goes on the bottom here. And we're going to match these up. This is R and this is F. Alright? It just happens to be that way. That's R and that's F. We're going to match this up. So 2 goes here, 2I. This is 3J. We don't have and then this is negative 1. And over here, we're going to get negative 1, 2, and negative 3. So now we have to set this up somewhat. This is step 1. But step 2, we're going to have to go into breaking this down into smaller chunks. So then we're going to go, you know, we're gonna set this up like this. It's nice to box this off in sort of like little boxes like this, because you're gonna see that I will connect with this chunk here. All right, I connects with this chunk, so it's gonna be like 3, negative 1, 2, and negative 3. This connects with the I, and then something really important to remember is that you're gonna have to do I minus j plus k plus I minus j plus k. This is how the end result is. Remember this little section here? It's plus I minus j plus k. That's how you're going to finish these. Plus I, this is the plus I here. Then we have a minus for the j. Well, how do we get j? Let's erase this. Well, actually, we kind of needed that. J is going to be, like, kind of weird. J is this and that. So it's like 2, negative 1, negative 1, and negative 3. This is j. And then we're going to put k, so let's get rid of this again. I know it's kind of weird, but you kind of have to just remember how to set these up. But you're just going to separate k off by itself over here and multiply that times this side over here. So you've got, you know, 2, 3, negative 1, and 2, and that's going to be k. That was basically how we break down this 3 by 3 matrix. 3 by 3 matrix, and we translate that into these 2 by 2 matrices over here. All right. We're almost done. All we need to do is just multiply these out. So if we know how to cross product these things out, it's just going to be like this. You want to kind of look at this as if you were reading a book. So you start with the letter with the number 3, and you're just going to start there. So it's 3, 3, and then over here it's 3 times negative 3. So 3 times negative 3. Just go ahead and I think we were going to subtract that. So subtract that from this side, which is going to be 2 times negative 1. Like this. All right. That's going to be our I. All right. And then over here we've got a minus j, so it's going to minus, and we're going to read this like a book. So it's going to be 2 times 3, 2 times negative 3, minus, over here it's negative 1 times negative 1, negative 1 times negative 1, that's the j, and the plus k, we're running out of room a little bit, let's go plus k over here. That's going to be like this, 2 times 2 is like here, 2 times 2, and then minus 3 and negative 1, 3 and negative 1, that's going to give us our k value. We can just add this all together. Remember that our answer is going to be a vector. So that's why we have 3 different components here. This is just going to be equal to negative 9 plus 2, which is going to equal negative 7. So we have negative 7i as our first piece of our answer. And then the second one is going to be, this one is like negative 6, and then plus 1, I guess. This is 1, and you're subtracting 1, so it's minus 1. So here's another negative 7j. And then the third one is over here. This is like a 4, and this is a negative 3, and you're subtracting it. So it's just going to be 7 on this side. That's kind of interesting. There's actually 7. Cool, 7k. So like that is the answer if we were to try to cross these 2 vectors. We get this answer. Remember before, if we dotted them, we just got a number, which was like negative 1 joules or something. But when we cross them, we get this whole vector, which is this 3-dimensional thing that, you know, kind of interesting. So that's how we can multiply vectors together with this math. Now it's going to be a lot easier to solve problems in the future. Just like and subscribe this video. You can even bookmark it in case you need to check out how to do vector math in the future. Hope it was pretty helpful.